Hello, everyone, and welcome back. Today, we are diving into part 2 of Generative AI All You Need to Know. In part 1, we covered the absolute essential, the foundational concept of Generative AI, its history, and the key technical terms you need to be familiar with. If you missed it, I have dropped a link in the description below. Please go and check it out because understanding those basics is crucial before we move forward. Think of part 1 as a launch pad for what's coming up next. So, what's on the agenda for part 2? We'll be exploring the diverse modalities within the generative AI. The term AI is everywhere, but what does it mean for you? We'll shift your perspective from being a passive consumer to an active creator. How can you harness the power of AI in your job? What are the essential tools and frameworks that can help you to get started? We are going to break it all down in this episode. The engine is running. So let's get start onboarding into the data AI Express and start the journey. First up, let's talk about text generation and large language models. LLMs are the very core, the heart of generative AI. But what are they really? Imagine taking all the information on the internet, every article, every book, every conversation on Google, and feeding into a single model to train it. That was the initial idea. As we discussed in the part 1, the transformer architecture is what makes this possible, allowing the model to process vast amount of text data. They feed these models trillions of words, teaching them to recognize the pattern and relationship in languages. For example, if you train a model on countless calendars, then ask, what month comes after August? It will confidently say September. It's not just thinking, it's predicting the next most likely word based on the pattern it has learned. This process has been repeated for numerous languages, not just English. Today, a staggering 80% of AI use cases in the industry revolve around the LLMs, processing structured and unstructured text data. Mastering LLM means you are equipped to handle the vast majority of AI challenges. So, who are the major players in this space? We have OpenAI's GPT, Meta's Llama models, Google's Gemini models, Elon Musk Grok, and Anthropic Claude. These models are the front end of innovation. The applications are endless. Creative writing, generating stories, poems, script. You can literally create novel narratives with simple prompt. Summarization, condensing long article, email chains, or even meeting notes into concise summaries. Think about how the Microsoft Teams can now summarize your meetings. Virtual assistant and chatbot. This is the game changer for the customer service. Chatbots are everywhere now, handling complex queries and guiding the user through processes, making them indispensable in BPO centers. Code generation. This is the must known for our developer community. AI can now write code, it can translate, it can create data migrations, debug code, significantly speeding up the development projects. Content creation. Need to draft a professional email or brainstorming ideas for Blogspot. LMs can do it in seconds. All these powerful applications are built on foundation of languages. And the exciting part, you can now build your own AI application using these LLMs. Next, let's move from text to visuals with image generation. The principle is simpler. Just as an LLM predicts the next verb, image generation model predicts the next picture. These models are trained on billions of images from the internet, learning to associate words with visual context. They know what a sun look like, what a moon look like. By providing the text prompt, you can instruct the model to create entirely new images. For example, you could say, create an image of an astronaut riding on a horse on a Mars, and it will generate it for you. This allows for incredible artistic innovation. Some of the leading models in this space include Midjourney, DALL-E, Stable Diffusion. These tools can generate stunning proto-realistic images from simple text description. We will explore how these tools, along with code generation assistance, are changing the creative and technical workflow in the future videos. Now let's turn to audio and music generation. The media industry is on the verge of massive transformation because of these technologies. Imagine composing a symphony by simply describing it. You can specify the mood, the tempo, and the instruments, and the AI will generate the music for you. This is also revolutionizing the sound design for the films and games. Need a suspenseful background score or a surprising sound effect? Just a prompt to the AI. This is already being widely used by the YouTubers and the game developer to create unique audio experiences. Following audio is video generation. The concept is same, but complexity is much more greater. OpenAI Sora is a groundbreaking model that can create incredibly realistic video clips from the text prompts. Google can also enter the ring with the models like Imagine 2 and Veo. These tools can be used to create animations, short films, and even transform existing videos. The potential for content creation is immense. So let's do a quick recap. For text, we have powerful LLMs like GPT-5, GPT-4o, and Claude. For images, we have DALL-E and Midjourney. For audio, models from platforms like Eleven Labs are leading the way. And for code generation, tools like GitHub Copilot are indispensable. We'll do a deep dive into GitHub Copilot and how to build applications within a minute in the future videos. Now that you know about different models, how do you actually use them? Let's clarify three key concepts: OpenAI, ChatGPT, and APIs. OpenAI is the company, ChatGPT is their user friendly web application. But the real power for the developer lies in the API or the application programming interfaces. While you can directly work with ChatGPT through the web, you can ask numerous questions on its website. This is not a scalable for building an application. To do that, you need the API. Think of an API like a waiter in the restaurant. You, the developer, give the waiter the API, your order, a request. The waiter takes the order to the kitchen, which is an AI model, which prefers your food, which is the response back to you, right? The waiter then bring the responses or the finished dish back to your table. So your API request can be very specific. You can specify which model to use, what parameter to set, how you want the output formatted. It's like telling the waiter you want your steak medium rare with the side of mashed potato and so on. The API takes this instruction, process them, and return a tailored response to you. This is the magic behind the building the scalable AI application. You might also hear the term endpoint. An endpoint is simply a specific URL for an API that performs a particular function. Large companies might have different endpoints for different teams, different projects, different domains, ensuring that each one has the secure and specific access to the specific AI models. To use these endpoints, you will need an API key, which is like a unique password for your application. So, how do you start building? You will need an endpoint for the model. You deploy this in a cloud or even run it locally on your desktop. For local testing, a fantastic tool is Olama, which allows you to run various open source models for free without needing an API key. However, for enterprise level cloud based deployment, an API key is essential. Let's go over the developer tech stack. Frameworks. Tools like LangChain, Llama Index can help you to structure your AI application. What if the AI needs knowledge beyond its initial training? or the customized data. This is where the vector databases like Pinecone or Quadrant can come in. You can feed them your company specific, like encyclopedia or your internal documents, creating a specialized knowledge base for the AI. Here, the AI model will not learn from the domain specific data that you supply, but it can use the knowledge base for its prediction. Data extraction. Often your data is logged in PDF on the websites. Tools like Beautiful Soup for web scraping or LlamaFace for document extraction can pull this data out and convert into a usable format so that LLM can make use of it. For example, you could extract the text from a PDF, feed it into an LLM, then build an application that can answer question about the document. This process requires context. You can't just ask question. You need to provide a right background information. Who is asking? What is their goal? The more context that you provide, the better output will be. When building an AI application, if your input, the context fits within the model context window, which is like 5,000 tokens, for example, you can directly interact with it. However, if you're working with a large knowledge base, like an entire company documentation, you need more advanced technique. This is where RAG, Retrieval Augmented Generation, RAG, comes in. With RAG, you first break down your large documents into smaller chunks. These chunks are then converted into numerical representation called embeddings, and stored in a vector databases. This is called vectorization. When you ask a question, the system first searches for the vector databases for the most relevant chunks of information. It then augments your prompt with this retrieval information before sending into the LLM. Think of it as like instead of sending the entire company information, you're just sending some relevant information to the AI and ask them to predict the next word for your use case demands. Next, let's talk about agentic AI or AI agents. An agent can perform a series of actions to accomplish a goal. It's like giving an AI a to-do list. For example, you could create an agent that sets 7 a.m. alarm. If you don't wake up, it will wait for 5 minutes. If you still not wake up, it sends a text to your spouse. This chain of thoughts allow AI to automate complex multi-step tasks. This is where the fear of AI taking the jobs comes from. As companies are now automating the repetitive tasks that were once done by a lot of human beings, right? So that's where everybody is now afraid of AI is there to automate their task. Finally, let's cover some best practices. Security. This is your top priority. Never train public AI models on your sensitive company information or production data. Stick note to that. Human in loop. AI is not perfect. Always have a human review of the output. Especially in critical application, we aim for continuous improvement by capturing the user feedback to refine the model's accuracy over time. Accuracy. No generative AI solution is 100% accurate at the moment. Most top at around 80 to 90% is the best accuracy that every company can give. Do not deploy these solutions in situations where 100% accuracy is required without human oversight. Monitor and iterate. Continuously monitor the model's performance. Is the accuracy dropping? Do we need fine tuning or to improve the context with RAG application? You have to closely watch the output. Cost is a huge factor. Every question you ask, every responses you get, it costs money. The faster and more powerful model, the higher the cost it is. When moving from testing to a production environment with many users, you must optimize every step of your engineering process to manage cost effectively. Okay, we have reached the end of our journey for today. We have covered the different types of AI models for text, image, audio, and video. We have demystified APIs and endpoints and discussed how to build the application using techniques like RAG, and AI agents. We also want over the essential best practices you need to follow. I hope you found this video very useful. If you have further question, please put it in the chat. What's interested makes you from this learning. Until we meet again in the next interesting topic, this is Data AI Expert signing off. Thanks everyone.